Good day, everyone. This is Bill Sigmund, Director of Sales Engineering for phoenixNAP. Our guest today is Craig, who's Senior Director of Product Management over at Supermicro. For
Good
those of
morning.
you, let's quick poll questions. First one is, what kind of IT infrastructure are you using for your workloads? Public, private, or multi? We'll give you guys about 15, 20 seconds to answer that, and then we'll share results. Okay, kind of what we thought it would be. Public cloud being chased very closely by multi-cloud and on-prem. Let's go ahead and close that. And one more quick poll question if we can. Let's do that one as well. What do you think factors your performance goals the most? Hardware, connectivity, storage, all the above, or something else? We'll give you guys 15 or 20 seconds to answer that as well. Okay, so a lot of all the above answers there, which is a good thing because that's what we're going to talk about today. So what you're seeing today, well, I should say what we're seeing today is AI and compute intense workloads are driving everything. We all know that, right? The problem is about 30% of people claim that their IT environment can handle these workloads, and 70% say in some major or minor way they just don't think it's there. We're definitely seeing the demand driving or being driven by AI. So we're seeing a lot of training and inference. And we're seeing a lot of other stuff too, but mostly it's training and inference these days. Networking, oddly enough, people are still power hungry for networks, so we're seeing that climbing up too. So what are we seeing the most of? Obviously, multi-cloud is starting to dominate. I mean, we're seeing 86% usage today. I would say 6 or 8 years ago, that number was more of about 10%. Obviously, recent outages by the big hyperscalers, out of control spending on some of these hyperscalers is making some folks repatriate either into their own private cloud or going multi-cloud with other clouds. Um, People are finding obviously the most, which probably doesn't surprise anybody on this, is the managing the cloud spend is the biggest driver behind that, right? I mean, some folks get these out of control bills that surprise them. It's hard to budget for. It's hard to smooth out. Obviously, we've had some security problems in the last 3 or 4 years as well. And then, of course, those folks that need expertise in these public clouds that obviously require expertise just to be able to maintain and run them. So what we provide is on-demand bare metal. And what that means is it's consumable with an AWS GCP type environment, right? I want to just spin this thing up, not worry about the hardware, not worry about the software stack, et cetera. I just want to take it as a consumable. And that's what we're seeing right now. The other big driver behind it is obviously automation. So our API allows you to use all those normal tools, your Ansibles, your Terraforms, the stuff you use today in the public cloud can be used with our bare metal as well. And obviously the big drive behind the bare metal side is you get all of the compute resources and you're actually kind of walled garden away from all the other users. So you're not actually sharing the same compute resources. So it helps with management. It helps with quick deployment. It's super predictable. You know what your bill is going to be every month because it's not bursting. It's a server. And you get the newest technology with us. And with that, Craig, I'll hand it over to you, sir.
Yeah, good morning, good afternoon, good evening, depending on where you're at. Thank you for joining. Appreciate your attendance and welcome you. Let me talk a little bit about some of the hardware that sits behind the infrastructure. I'm with Supermicro. Supermicro here, we are a U.S. company. We have facilities all around the world, but our main facility is in San Jose. We actually design, build, and manufacture these machines and racks level solutions in San Jose. We're about we have production for about 5,000 liquid cooled racks per air cooled racks per year and 3,000 liquid cooled racks. That's about 250 liquid cooled rack stations, which is the largest of any vendor. We got 7,000 employees worldwide, so we still are relatively small on the headcount side compared to our, you know, tens of thousands, if not 100,000 competitors. And we still do our own designs. We build our own products. We design them when we have issues. We have the design engineers who can quickly resolve those. even the toughest problems, which tend to be intermittent issues, we can solve those because we are the ones who build it. We don't depend upon others. Um, Year over year, if you know Supermicro, we've grown like crazy. We partner with all the chip vendors. We are agnostic from that perspective. And the claim to fame for Supermicro is we are extremely, extremely customer focused. phoenixNAP being one of our best. So when you buy Supermicro, you're buying more than just the hardware. We put a lot into the business protection from cradle to grave, and I'm not going to read all the bullets for you. But what I want you to understand is that we have very strict processes. We're ISO certified. The vendors we buy our components from are ISO certified. We do our own manufacturing. We have made in the USA products. We can do any product in our portfolio made in USA. And if you're familiar with that, it's a step above the standard TAA compliance that the government has. We track our parts. We know where they come from. We know what lot, engineering lot they came out of. We have the serial numbers, everything. It's very strict. We know what memory devices we get, what's stored in each memory location, and we publish how you erase those memory locations for security reasons. We do all the very strict government certifications. In fact, we work very closely with the government. We have a U.S. Air Force co-research and development agreement to secure our supply chain risk management from them coming in every quarter and auditing us and giving us suggestions for how to improve our risk management. We are self-certified on CMMC, and we are going for, once they have the auditors assigned, we will have a CMMC2 certification, which is very strict. And for those of you who do worry about, if you wouldn't mind going to the next slide, for those that do worry about where does the security start? For us and for many vendors now, it is root of trust. And if you're not familiar with root of trust and you're wondering why I'm putting this slide up here, is the things that we worry about the most in the server industry is somebody coming in and spoofing our firmware. And the way you prevent that is you don't put your authentication in firmware. You put your authentication in the silicon. And in the BMC that we use, which is the AST 2600, as you can see in the slide, we have 6 locations for our certificate authority. And the first thing the servers used to do in the olden days was look for its bootstrap. The first thing servers do today, the parts when you plug it in and power it on, the first thing those chips do now is they look for authentication of the firmware. And so if it finds that it's not Supermicro firmware, the system will actually lock up. It will not boot up, and there's no way around it. It has to validate Supermicro firmware and or whatever certificate is in there. We actually have 6 locations, and if somebody wanted one of our locations, we can make that happen and give them their own firmware release. But this allows us to start the process, and what happens is the firmware validates the bootstrap. The bootstrap validates the drivers, the operating system. All these layers can go all the way up to the application. For governments, for our military in the US, they actually use that whole authentication process all the way up through the applications, through a special version of Linux, all the way up through the application. So it's very strict, and it's an industry standard that we comply with. In Supermicro, what I want you to understand is not only do we build our own products, but we build it in efficient ways. If you own Supermicro, you would do the same thing we do to save time, save resource, save on SKUs. We make our products so that those components can be shared across the portfolio. And that does 2 things. It allows us to customize machines when nobody else will customize, but it also allows us to drive the quality up on the components because they are shared. We can see many different use cases for that particular, let's call it a riser card, or the motherboard. So we reuse what we can, and we reduce our SKUs and our stock, but we also drive the quality up this way. And we are very engineering focused at Supermicro, as I talked about earlier. If you want something, or if your customer needs something, if phoenixNAP comes to us and says, you know, we like this, but we really want this other riser in there, this is something we can do pretty easily in Supermicro. So for phoenixNAP, we build and support these three major platforms. And they are, we call them multi-nodes. The industry calls them multi-nodes, and that's because they are in a chassis where there are multiple nodes, and those nodes share some critical infrastructure. And why would you do that? There's a couple of reasons why you would do that across this portfolio. One is I can use one piece of sheet metal and support many servers, but I'm sharing not only sheet metal, I'm sharing the fans, and those fans are larger fans. I'm sharing the power supplies, and in some case, I'm sharing switching infrastructure. And that is important because the larger the fans, the better your energy efficiency, and the better the energy efficiency for phoenixNAP, the better your price on your bare metal purchase. So all of these add up to, we want to save space, we want to save energy, which is the most important commodity these days. But I also want to make sure I can give my customer the best deal possible, and that's why you see these multi-nodes. And I won't go through all the information here, but the slides, take a picture, or you can ask for them afterwards, and be happy to share them. So we'll deep dive a little bit into each one of these. I'm not here to bore you, but I want you to understand what you get when you decide to center in on a platform. With the Big Twin, you can get some of the highest performance, I should say it that way, the best performance processor with the Intel 6700, which allows for the best performance per dollar in I'll say a enterprise type of application. The Big Twin has many configurations for storage. Just showing you a couple here, but it has 4 nodes in here, or 2 nodes. You can see here there's a 2U4 node picture, and there's a 2U2 node picture. And the reason we do those is we can use higher capacity SKUs, or we can use larger or broader IO card offering, even double width GPUs. And this is important because in one platform, you can deliver high energy efficiency, high performance, lots of storage configurations, and even if you wanted to, GPU enable hybrid solutions. So for Big Twin, it's small enough that you can do just a few apps, but it's also big enough that you can drive your biggest applications. Grand Twin is a single processor multi-node, so similar to Big Twin, but you have a single processor, and we are seeing migrations from 2P to 1P because of the coherency bus that disappears, and the SKUs are getting hotter, which make them more difficult to put into a 4-node 2U. But it also has the capability to be IO focused or storage focused, and you can have a rear IO, which gives you lots of storage options in the front, or you can have a front IO, which allows for cold IO service of everything in the system. But you still get the efficiencies of a multi-node. So these nodes are all sharing 80 millimeter fans, which are much more efficient than the 1U fans, the 40 millimeter fans. And so that drives energy costs down. You can put more servers in in a fixed amount of energy. Energy efficient, very flexible. You get a single processor, and these processors with Grand Twin, I should have mentioned, can go up to the top bin SKUs, even the 400 and 500 watt SKUs with our EVAC cooling solution. And that's really important when you're talking about AI, and you want to use that AMX to max it out and use the higher bin SKUs. It is a critical feature, and it's 12 DIMM channels, so you get a very high memory bandwidth, much higher than you would in a standard SP SKU, which is 8 channels. It's about a 23% improvement in memory bandwidth. Next slide, please. And then finally, we have the microblade. And the microblade for best performance, best dollar per node, the density, it also shares fans, but in addition, the microblade, because it is a blade infrastructure, also shares switching fabric. And so you share power supplies, you share the fans, and you also can share switching. The switching can be redundant or non-redundant, depending on how you like to drive your environment. And there's the things you probably care less about, but it's the chassis managers can be a single chassis manager, or you can have redundant chassis managers. So driving your costs down, both energy costs and your acquisition costs, your CapEx, is where microblade has the advantage. And this density in a 20 node configuration in 6U, that's three and a third servers per U, which is amazing when you think about it. And so you get that efficiency of CapEx. So you're using an i9 type processor. You get rack savings. You get cable consolidation because the switches are built into the infrastructure. You get power savings because you're sharing power across all of these nodes and keeping those power supplies in its maximum efficiency range. And of course, you get the air cooling efficiency because you're using the larger fans, which can move more air per watt, which translates into dollars. In short, with Supermicro, we can help solve all your customer needs, and we can help get you to market faster. We have engineering resources here in San Jose, and we can solve even the toughest problems and make sure you get the best product for your dollar. Thank you.
Thanks, Craig. Appreciate it. A little bit about phoenixNAP. Not going to beat this to death too much. We have employees worldwide. Our flagship first data center was built in Phoenix. When you look at our portfolio, we go everywhere from co-location all the way up to hybrid VMware solutions. We've been around, well, I don't like 10 plus. We've been around a while, probably 15 plus at this point. So what is cool about bare metal cloud? Well, obviously we had Supermicro here because it's based on Supermicro. The nice thing about it, and I kind of touched on this earlier, is it is completely API driven. So whether your folks like to use Python, Terraform, Pulumi, Ansible, GitHub, we have plugins available for all those. Whether you're just firing up the server or whether you're maintaining the server, all those actions are built in with our API. We also have cloud APIs if you're more container driven, that's available as well. And APIs for configuration after the fact as well. All that's available on GitHub. Again, as I mentioned earlier, these servers are from hourly to annual to 3-year contracts, even monthly. So it's very flexible in how you purchase them. And of course, deployment in minutes, which I will show you in a little bit. So a nice thing again is, you're not dealing with hypervisors, you're not dealing with noisy neighbors, as I mentioned earlier. It's very, very, very cost competitive. But in addition to that, you know exactly what your cost is going to be every month. We don't hide behind extra costs. We have built-in storage as well as S3 compatible storage available right in there. And then we also, of course, have our all-flash network file storage as well. Layer 3 connectivity to other networks. Currently in Phoenix, as an example, we have over 45 networks in that building. So chances are we already have somebody in there that you're using. So it's really easy to connect to them. If you want to get to the hyperscalers, we also have Amazon, Microsoft, and Google in our data center. And some of the other smaller sites, we offer other ways to connect to them direct as well. All right. So as what Craig said, I don't want to bore you with the specifics. Everything you see in bare metal cloud is a newer generation server. We don't have 5 and 10-year-old servers out there. Everything is latest, greatest. So with that, let me switch the screen and show you guys a quick demo. Okay, so this is our bare metal cloud. As you can see, it's pretty simple. This is the landing page for home, and it's got all the links to everything right here. But as an example, I'll go ahead and just deploy a new server real quick so you guys can see the speed behind this thing. Let's go ahead and select Seattle. I'm going to choose hourly billing, but as I mentioned before, we have monthly or annual terms. I can do multiple servers if I want. In this case, I'll just do one. Let's say I want a single CPU and show me what's available in Seattle. Let's do this guy. We're going to select the S1C1 small. Run down here, I can choose whichever operating system I want. In this case, I'm going to use Ubuntu, but as you can see, pretty much any operating system you want is available out there. And we do have an option for custom OS as well. So if you don't mind doing a little programming with Terraform or Ansible, there's ways to do it that way as well. So in this case, we're going to go ahead and just say next. I'm going to take all the defaults here just so we can be fast about it. Sure, I'll take a public IP address. I kind of want that. And as you can see, we're off creating the server. Now, while that's creating, I'm going to run through here real quick and show you a couple other things. I mentioned the storage. As you can see here, you can create NFS or you can create an object storage pool. On the networking side, with our platform, you get per region 15 front-end networks, in other words, internet-facing networks, and 50 rear private networks behind that. You can purchase IPs on the fly right here by literally clicking add IP. And we do have full support for BGP. So if you want to use our ASs, bring your own AS, we can accommodate that as well. Then the normal account stuff, right? What's in my account? Who's the users? Real quick on the API credentials. If you're using our API, obviously you're going to need credentials to put in there. I'll give you an example. We'll just do a view credentials. This is your client ID and your client secret. They can be regenerated anytime you want, and you can copy those straight into your code. Now let's go back to servers. So as you can see, it says creating. I think I need to refresh. Let's go back. Okay, it's still working out its stuff. Good enough. Under billing, you of course can see your billing and usage. This is a demo account, so no, not everything is free. It's just marked free for me because it's a demo account. You can pull up invoices, past and previous. You can pull your payment history, as well as change or add credit cards for whatever you want to use on that. Now under here, let's do a view details real quick. So as you can see, here's all the specs. Here's my billing model. There's my start date. Obviously, the price says 0 because of that. And then for actions, and all these actions are available via the API as well. I can launch a console into it. I can shut it off. I can reboot it, shut it down, etc. Obviously, the console's there for if I fat finger an IP or some other reason can't get into it. We can get into the console no matter what. I'm going to go ahead and delete that. And as simple as that, it's deleting the server. So as you can see, it's very fast. It fires up the server in under 3 minutes, and you're off and running. And with that, let's do a bit of Q&A. So let's see what questions we have. And is everybody aware you can put a question in right there in the questions tab? I think we've got a couple questions coming in now. First question, what is the max clock speed of the E-cores on the i9? That's 4.4 gigahertz. Next question, if I consume them hourly, how much will these Supermicro servers cost in BMC? So yeah, you didn't see any cost there. As an example, the i9 is about 47 cents per hour. Obviously, if you went to a monthly or to an annual, that would be a lot quicker. Third question, which locations can these servers be deployed? So currently today, Phoenix, Ashburn, Virginia, and of course, Amsterdam in the Netherlands. And with that, everyone, I want to say thank you again. And thanks to Craig and Supermicro for coming along.
Thank you.
Have a great day.
Bye-bye.
Thank you all. Bye-bye.